In question 5, we're sticking with derivatives, but we want to specifically find the derivative of a function at a given value of x. We're told y is equal to arctan of x divided by x squared plus 1, and we want to find y prime of 1. Well, we can't find y prime of 1 without finding a general expression for y prime, so let's do that first. And the first thing we should recognize here is that we've got a quotient, and this isn't a situation where it would make sense to rewrite it as a product, because then we'd have the arctan of x times x squared plus 1 to the negative 1, which means we'd be trading off the quotient rule for the product rule plus the chain rule, which probably isn't a good exchange. So that's fine. We'll use the quotient rule, which tells us that the derivative will be the derivative of the numerator, so the derivative of arctan x, times the denominator, x squared plus 1, minus the numerator, arctan x, times the derivative of the denominator, x squared plus 1. And then we divide all of that by the square of the denominator. All right, well, there's the quotient rule used. Fortunately, these are both simple derivatives, no need for the chain rule or anything like that. You just have to remember that the derivative of arctan x is 1 over x squared plus 1. And then we're going to multiply that by x squared plus 1. Well, that should simplify nicely. And then we've got minus arctan x times the derivative of x squared plus 1. Well, x squared we can differentiate using the power rule. It's just 2 times x. And then the plus 1, because it's a constant term, we know that has to differentiate away to 0. So we're just going to multiply by 2x. That's all divided by x squared plus 1 all squared. And so we can certainly simplify here. 1 over x squared plus 1 times x squared plus 1 is 1, minus, we'd write that as 2 times x times arctan x by convention. Constant first, then the x, then anything else. So that's divided by x squared plus 1 all squared, and there's our derivative. But we don't just want the derivative here, we want the derivative when x is equal to 1. So that's fine. Y prime of 1 then is going to be 1 minus 2 times 1 times the arctangent of 1 divided by 1 squared plus 1 all squared. And so the only thing that's really going to give us any thought here is evaluating the arctangent of 1. And so what that means is we're looking for a number between negative pi over 2 and positive pi over 2 whose tangent is equal to 1. And well, that means that we're working in the first quadrant, because in that range, that's the only place where tangent is positive. And because tangent is sine divided by cosine, if tangent is equal to 1, that can only happen if sine and cosine are the same. And the only place in the first quadrant where that happens, we know, is at pi over 4. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. So tan of pi over 4 is root 2 over 2 divided by root 2 over 2, which is equal to 1. And therefore the arctangent of 1 is pi over 4. So this is going to be 1 minus 2 times pi over 4 all over 2 squared, which is 4. So we can write that as 1 over 4 minus pi over 2 over 4, which is pi over 8. Or we could write it over the common denominator and have it as 2 minus pi over 8. It really doesn't matter. They're both reasonable ways to write the answer to our problem. There's part A done. We'll move into part B in the next video.